Hey everyone, welcome back to the channel with another Leetcode DCC question. I hope you are doing extremely well. Let's look at the question. Find the pivot integer. Question says, given a positive integer n, find the pivot integer x such that the sum of elements between 1 and x inclusively equals the sum of all elements between x and n inclusively. Return the pivot integer x. If no such integer exists, return -1. It is guaranteed that there will be at most one pivot index. That means there can be an index or there cannot be an index. So question is saying, let's suppose we have a value n equal to 7. That means we have an integers 1, 2, 3, 4, 5, 6, and 7. So we have to find an index or a pivot such that suppose this is the pivot, then in that case, the left sum, total left sum, total left sum is equal to the total right sum. If this is the case, then this number is the pivot of this n equal to 7. So we have to find such pivot. So if we see in this example only, if we see the total left sum is 3 plus 2 plus 1, that is 6. And on the left side, the total sum will be 7, 3, 10, 20, 25. So that is not equal to total right sum. So this cannot be a pivot for 7. So like this way, we have to find out the pivot such that total left sum is equal to total right sum. So how we can solve this question? So the basic to solve this question, there can be various approaches. So we will see few of them. Let's see method 1. In this, what we will do, suppose for a given value of n, we will iterate the number from 1 to n, and for every number, we will check whether that can be pivot or not. So starting from 1, so the left half sum will be 1, right? And right half sum will be 1 to n. So we will see whether this sum is equal to this sum or not. If it is not, then we will move on to the next number. If it is, then we can return the that number straight away. Now, if 1 is not the pivot, then what we will do? We will add 1 plus 2 here. And from 2 to n in the right hand side, we will check whether it can be a pivot or not. Again, if it is not, we will add 1 plus 2 plus 3. And in the right hand side, we will add from 3 to n. So to add this number, do we need to iterate a for loop? I don't think so. So there is a formula to get the sum of n natural number. So if we have the sum of n natural number, that is n into n plus 1 by 2. So using this formula, we can get a total sum of 1 to n, right? And when we are checking for a pivot as 1, we can make left half sum as 1, and the for a right half sum will be this. Let's suppose this is the total sum. We can make it as total sum minus left half sum plus this one, that is that particular number. Let's suppose it is I. Now for 2, if we are at 2, so in the left half sum, we already have 1. Now we just need to add this 2. So we can make left half sum plus I. Let's suppose this is I. And in the right half sum, again, it will be total sum minus this will be our new left half sum. Again, we can do left half sum plus I. So in this way, we can see, we can calculate for every number. For every number, I, we can calculate left half sum and in O1 time, and the same as for right half sum in O of 1 time. So by this method, we can solve, and for every number, we can check whether that can be a pivot or not. So by this method, we can easily find the pivot, and overall, it will take big O of n time because we are iterating every number from 1 to n and checking whether that can be a pivot or not. So if all the numbers from 1 to n is cannot be a pivot, in that case, we will return -1. So this can be one approach. So in this time complexity, we have seen overall time complexity, it will take big of n. So can we optimize it further? Let's see. Let's see method 2. And before jumping onto the solution, let's analyze something. Suppose we have given a number 1, 2, 3, 4, 5, 6, and 7. Now, suppose we are at point this, and we know the left half sum will be 3 plus 2 plus 1, that is 7, and right half sum will be 7, 3, 10, 25. Now we will check whether the left half sum is equal to right half sum or not. It is not, right? So at this point, can we identify whether if there is a pivot, whether that pivot will fall in the left hand side or in the right hand side, whether we have to move the left side or the right side? Can we judge at this point of time? So since we can see the left half sum is less than right half sum, that means to make it equal, we have to increase something here, and decrease something here. So if we move towards right, then only we can do so, right? If we move towards right, then this thing can happen. We can increase the value of the left hand side and we can decrease the value of the right hand side. But if we move on the left hand side, the left hand side value will decrease and right hand side value increase. So this step will not lead to the solution, because in this way we will never get the left hand side equal to right hand side, right? If we move towards the left. So by looking at the current point, the left hand side and the right hand side, by looking at this point, these two values, we can identify whether we have to move towards left or move towards right. So when such things, or when we can find out that whether we have to move left or right, so such scenarios can be solved using binary search. So how we can solve it? Suppose given a number from 1 to n, we will first jump to the midpoint and see whether the left hand sum is equal to right hand sum or not. If it is not, either if it is equal, then we can say, yeah, that is the pivot point. If it is not, either LHS will be greater or RHS will be greater. Only these two cases can be arise. If this is the case and we want to make it equal, then definitely we have to reduce the LHS and increase the RHS. In that case, that means we have to move left. And if RHS is greater and LHS is smaller, that means we have to increase RHS and decrease, increase LHS and decrease RHS. In that case, we have to move right. So if we do so, so the time complexity for that will be, in this case, the time complexity to find the pivot will be big O of log n, because every time we are dividing the full range. So initially, the total range of the answer will be 1 to n. Now, once we find the pivot, so suppose this is the middle point and we try to find out the answer. If this is not the pivot, now the next range of our answer will be either 1 to n by n minus 2 or n minus 2 by n. So it is reducing to half. That means initially our range of answer was n. Now it will be n by 2. After that, it will be n by 4. Like this, we are decreasing n by 8. So in this way, we can see the total time complexity will be big log of n. So what we are happening? So if we do the summation of n by 2, so this will, so there will be number, if we go till 1, that means number of instances will be log of n. That's why the total time complexity of this solution will be big O of log of n. So we have definitely optimized the solution. Let's see the code of this method too. So initially our low value, that means we have a 2 pointer. Let's suppose the low pointer is at 1 and the high pointer is at n, and we will find out the midpoint. So here we are finding out the midpoint. No, here we are finding out the total sum. To get the sum of left hand side and right hand side in big O of 1, we are already calculated the total sum of numbers from 1 to n. Now we will find out the midpoint. So this is the midpoint. Now we are finding the first half of the sum, that is mid plus 1 by 2. And for second half of the sum can be total sum minus first half of sum plus mid. If the first half sum is equal to second half sum, then we can return that element as the pivot. So in this case, when the first half sum is greater than second half sum, that means we have to reduce the first half sum and increase the second half sum. That means we have to move towards left. And if the second half sum is greater, that means we have to increase the left half sum and decrease the right half sum. In that case, we have to move towards right. So in this way, we are adjusting the low and high pointer. So if in the while loop, we are not getting the answer, we are not getting the pivot anytime, that means for this number value n, there is no pivot. In that case, we will return -1. I hope the problem statement and the solution is clear. If you have any questions, mention in the comments below. See you in the next video. Thank you.